So we'll continue solving our linear systems here. This one is solving linear systems in 3 variables. And you can see our system of equations here in the 3 variables, x, y, and z. And of course, you can see that we have ruled paper here. That's always a good idea just to keep everything nice and organized. But the first thing we'll do is we'll change this system into a augmented matrix. So we'll do that right here. And of course, we will have our coefficients here, 2, 2, and 1. Put in our vertical line. And of course, then we're going to have our matrix of constants here. That'll be 1. Then I could close off the matrix. The next row here, -1, 1, 2. And then for our constant, that's 3. Then we have 1, 2, and of course 4, and our constant is 0. And again, this column here represents our x variable. This column here represents our y, and of course the last column here will represent our z. And these are the columns that we do our elementary row operations on. So of course the idea is to change each one of these columns into a unit column. I'm going to write that up right here. Into unit columns. And again, unit columns are where only one value in the column is a 1 and the rest of the values are zeros, and we use those elementary row operations to do that. And our goal is to have a diagonal of 1s across here. So it doesn't really matter where you start, but try and make it easy on yourself. I like to take the path of least resistance. So you can see right here for our y, which occurs usually right in the middle, I have a 1 right here. So I'm just going to kind of work around this one here. So then I'm going to change this into a unit column. And it doesn't really matter if I start with this value up here, this one down here. I'm going to start with the top one up here. So I'm going to take row 1. And we'll subtract out 2 of row 2. That's going to be our transition. So then right here we have -1. -1 times 2, that's -2. So then 2 minus -2 is the same as 2 plus 2. This becomes 4. 1 times 2 is 2. 2 minus 2 is 0. And of course, that's the whole idea. 2 times 2 is 4. 1 minus 4, this is -3. Then we put in our vertical line. 3 times 2 is 6. 1 minus 6, -5. We can close off our bracket and then fill in the rest of our values here. -1, 1, 2, and then 3. And then 1, 2, 4, and then 0. So of course what I like to do is I like to go ahead and fill out the row that's going to change or adjust first, and then fill in the rest. I just copy over the rest. So we could see that our transition here, row 1 minus 2 times row 2, and this is the change that occurs. So now we'll change this into a 0. So we'll take row 3 and we'll minus 2 of row 2 again. So that'll be our transition to there. So again, we have -1 times 2. That's -2. 1 minus -2, that's the same as 1 plus 2. So this becomes 3. 1 times 2 is 2. 2 minus 2 is 0. That's the whole idea. 2 minus 2 is 4. 4 minus 4, 0. Put in our vertical line. 3 times 2 is 6. 0 minus 6, that's -6. Now we can close off our bracket here. And we fill in the rest of the values. 4, 0, -3, and -5. -1, 1, 2, and 3. So So we have now changed this column into a unit column. So we're done with this column. And if you see right here, I have a only one value in this row. And I want to go ahead and get that diagonal going. So what I'm going to do is I'm going to swap out row 1 with row 3 here. So we'll do that. We'll do row 1. We'll do this double arrow here. That means it's going to interchange with row 3. And then the result will be, we'll have 3, 0, 0. Our vertical line, -6. Close off our bracket. -1, 1, 2, 3, and then 4, 0, -3, and -5. I'll change this into a 1. So I'll take 1/3 of row 1. Three times 1/3, or 1/3 times 3, that's 1. Then we have 0, 0, our vertical line. 1/3 times -6, that's -2. Close off our bracket and fill in the rest of the values. So we'll continue changing this column into a unit column. So now we will simply just add these two. So I'll take row 2 and we'll add row 1. -1 plus 1, that's 0. 1 plus 0, that's 1. 2 plus 0, that's 2. Put in our vertical line. 3 plus -2, or in other words, 3 minus 2 is 1. Close off our bracket and fill in the rest of the values. 1, 0, 0, -2. 4, 0, -3, and -5. We now change this into a 0. So we'll do row 3 minus 4 of row 1. We'll continue down over here. 4 times 1 is 4. 4 minus 4, 0. That's the whole idea. Then we have 0 here. -3. Bring in our vertical line. -2 times 4. That's -8. -5 minus -8, or in other words, -5 plus 8. That's 3. Now finish in our bracket and enter the rest of our values in. 0, 1, 2, and then 1. And then 1, 0, 0, and -2. So now we have this as a unit column, this one as a unit column. The only one we have to change now is this one. So we can go ahead and start with right here, because we want to get our diagonal in of 1s here. So we'll take -1/3 times row 3. -1/3 times -3. We're going to have 0, 0, 1. That's the whole idea. Put in our vertical line. This becomes -1. Close off our bracket. Fill in the rest of the values here. 0, 1, 2, 1, and then 1, 0, 0, and -2. So our last value to change is this one right here. So we'll take row 2 minus 2 times row 3. 1 times 2 is 2. 2 minus 2 is 0. So we have 0, 1, 0. Bring down our vertical line. Negative 1 times 2 is negative 2. 1 minus negative 2 is the same as 1 plus 2. So this becomes 3. And we close off our bracket. Fill in the rest. We have 1, 0, 0, negative 2, and 0, 0, 1, negative 1. And as you can see, we have our diagonal here. This column represents the x's. This represents the y's, and this column represents the z's. So if this is the only x here, then x must be equal to negative 2. So we'll just write it down up here. X is going to be equal to negative 2. Then y is equal to 3. Y is equal to 3. And finally, z is equal to negative 1. So if this is the solution to this system here, then if we slug in these values of the variables into each of the linear equations here, it should satisfy all of them. So we'll go ahead and we're going to check that. So we'll take the first equation here. 2 times x, and of course x is negative 2. 2 times negative 2. Plus 2y, and y is 3. Plus z, and z, of course, is negative 1. And of course, all of that should equal to 1. 2 times negative 2 is negative 4. 2 times 3 is 6. Negative 4 plus 6 is 2. And 2 minus 1 is 1. So it works for the first equation. Let's do the next one. We have negative x, and of course, x is negative 2. Plus y, and y, of course, is 3. Plus 2z, and z is negative 1. And that should all equal to 3. Negative negative 2, that's 2. 2 plus 3 is 5. 2 times negative 1 is negative 2. 5 minus 2 is 3, so it satisfies this one. Let's do the final one. We have x here, that's negative 2. Plus 2y, and of course y is 3. Plus 4z, and z is negative 1. And that entire thing should equal to 0. So we have negative 2 plus 2 times 3, which is 6. Negative 2 plus 6 is 4. 4 times negative 1 is negative 4. And 4 minus 4 is 0. So it does satisfy the system. And this will be the only solution for this system. So it does seem to check out. And we're good to go.